The last question asks for when is the speed a maximum and when is the speed a minimum? So for that one, I would like to visit, if I can pull this up. Oops, my bad. All right, so for that last one, when is the speed a maximum, when is the speed a minimum? We know that the velocity vector is -3 sine of t, 2 cosine of t. We answered that one back in part B, right? So if we actually don't plug in a value for t, because we don't know when the speed is a maximum or a minimum, if we don't plug in a value for t, then we can find the value of t that yields a maximum or minimum speed. So we can do that by saying that the absolute value of the velocity function, which is the speed, equals the square root of dx dt, which is -3 sine of t squared, plus dy dt, which is 2 cosine of t squared. And a square root function only makes numbers smaller. It won't make them bigger. So to maximize or minimize what's inside of there, we just find the maximum or minimum of what's inside. So if you actually square this, you get the square root of 9 sine squared of t plus 4 cosine t, cosine squared of t, sorry. And so this is kind of like a little trick along the way, a trick of the trade, if you will. But we do know that Pythagorean identity that sine squared plus cosine squared equals 1. But that only works when their coefficients are the same. So a little trick of the trade, I guess you could say, is to split apart that sine of t and leave 5 of them alone. And then trade in 4 of them so that we have 4 sine squared t plus 4 cosine squared t. And now we can rewrite that as 5 sine squared t plus 1. And again, the reason you would want to do that, or I'm sorry, not plus 1, plus 4. The reason you would want to do that is because it's difficult to tell when you have sines and cosines in your answer. It's difficult to tell where that would be a minimum, but it's pretty easy to tell where this would be a minimum. First of all, if I'm squaring sine, I know that it can't ever be negative. So the smallest number that it could be would be 0. And where will sine equal 0? At 0 and pi, right? So I know that it has a minimum, that sine will be, or that this function will be a minimum at 0 and pi, because that's where sine will equal 0. And I know that it will have a maximum. What's the biggest number that sine could be?
1.
The biggest it could be is 1. Where will sine equal 1? At pi over 2 and 3 pi over 2. So that's the biggest it could be, which means that whatever inside of that square root will be a maximum there. So that's how you can minimize or maximize the function to figure out what it should be, what values of t will make it min and max.
I would think of a complicated way and say it equals to 0.
Set the whole square root equal to 0?
But that won't get me anywhere.
Only if you took the derivative of it again and then set the derivative equal to 0 and found the critical points. That would give you maxes and mins of this. But yeah, sometimes it's easier just to go back to the old-fashioned way of finding maxes and mins. All right, good. So that's how you would find the maxes and mins. If you think about it on that ellipse that we were looking at, 0 and pi, that's the two major endpoints. So that's where it's going the slowest, actually. And then at the top and bottom of the ellipse, the two minor endpoints, or not endpoints, what they call vertices. Those aren't really, I call them minor vertices, whatever. That's where it's going the fastest, is at those 2 points. All right. Here's my next question for you guys. Would you... Say it again?
What if you did it instead, like, I was going to say you split out the 4 cosine squared t, but that would be dumb.
Gotcha. Yeah, probably just split it up to the minimum amount of work possible. So my next question for you guys is, would you rather do another example like from this section, or do you want to go and start working on multiple choice problems like what we're going to see tomorrow?
Like what we're going to see tomorrow.
Okay. All right, so here's the answer to that question. So there's a question like number 32 on your test tomorrow. So what is the area under the curve described by the parametric equations x equals 2 cosine t and y equals 3 sine squared t, where 0 is less than t is less than pi? So how do we feel about that one?
Don't you know the equation for area?
Yeah. And do you know the equation for area?
I forgot. I need to study.
So first you have to eliminate the parameter to get it back into rectangular form, and then you can figure out what, well, there actually isn't an equation for area. The goal is to eliminate the parameter to put it back into rectangular form, and then you can just take the integral, because the integral will be the area underneath the curve.
Oh,
So if you just take the integral from 0 to pi of the rectangular form of this equation, then that'll be the answer for it. So Jolie, you said you had done it. Michael and Igioma, you said you had not?
Yeah.
All right, so do you guys want to try it, or do you want to just do it together right now?
I want to try it.
All right, so why don't you guys try and eliminate the parameter first, and then go ahead and take the integral of it from 0 to pi, see if you can get one of those answers up there.
You eliminate the parameter.
And when you're done, you can check your work for that one up here. So number 32 from the Parametric Equations Worksheet I emailed home.
Isn't it like x equals r sine something? Like
Good. X equals r, so 4 theta times sine of theta? Or is it cosine? I think cosine for x, yeah. And y equals 4 theta times sine of theta. So now that you have the two parametric equations, you can just do dy d theta over dx d theta, and that will give you the slope, and then you just plug in what theta equals to figure out what the actual slope at that point is.
Is the answer D?
I got D, yes.
Okay, wait, you just need to find the slope.
For tomorrow's, yeah, you just need to find the slope. But on this one, it's actually not that much harder to find the actual point, because you just plug in what the slope is back into x and y to figure out what the x and y point would be, and then just plug it into slope-intercept form from Algebra 1.
Is theta in this case like a function, so you do the hard code?
Yes, theta is like x in this case.
Wait, when you plug it back in, so you plug the -2 over 3 pi back into theta to find x?
No, so to figure out what the x and y coordinates would be at theta equals 3 pi over 2, you would actually plug 3 pi over 2 into theta to figure out what x would be and what y would be.
2 over 3 pi.
Are you talking about the slope? Or the
Oh,
actual?
okay, yeah, I get you.
So I plugged in what they gave me up there in the actual equation, 3 pi over 2. I plugged that into x, and I plugged that into y to figure out what x and y would equal at that value of theta.
Wait, so to find the slope, you find the derivative of y and the derivative of x.
Yeah, so to find the actual slope, so dy dx, or, yeah,
Remember, Michael, we learned that in your
equals dy d theta. So that would be, you have to use product rule, but essentially 4, because that's the derivative of 4 theta, would be 4 times the second cosine of theta plus the first, which is 4 theta, times the derivative of the second. So the derivative of cosine would actually be negative sine of theta. So this changes to a negative sine of theta over the derivative of dx d theta. Oh, I did the wrong one, huh? I did dx d theta on top. So let me just copy that to the bottom. And then on the top, it would be dy d theta, which the derivative of the first is 4 times sine of theta plus the first, which is 4 theta, times the derivative of sine of theta, which is cosine theta. So that's the slope function, the function of the derivative. To figure out what the derivative is at 3 pi over 2, you just plug that in everywhere you see a theta on top and bottom, and then simplify.
And that's the slope.
And that'll be the slope.
Okay.
So for tomorrow's quiz at least, or for tomorrow's test, that's all it asks you for is the slope. For this specific problem, it would ask you for more than that, but that's all you need to know how to do for tomorrow. Alright, so there's those. Let's see what else it's going to cover. How did I get negative 6 pi?
Yeah.
Back into it.
Yeah, if you take, here, let me put it like this. If you take this value,
Back into what?
No, it's looking for 3 pi over 2.
Oh.
yeah, take 3 pi over 2 and plug it in here for x, everywhere you see a theta, to get what x value it would be, and then take it and plug it back into y to figure out what y would be, and then you just use point slope formula. Y minus y1 equals the slope times x minus x1.
Okay.
And I think y1 happens to be 0, so therefore x1 is just 6, negative 6 pi. All right. All right, let's look at 49 on that same worksheet.
This is not expecting me to do 40 questions in a night.
All right, so this is another, and you get to use a calculator on it. So on the test tomorrow, you can also use a calculator on this question because it's too difficult to do by hand. So it says a path around a park is in the shape of a polar graph, r equals theta, as shown in the figure to the right. If the walker starts at the origin and walks around the path, and then back to the origin along the x-axis, how far does he walk? So, oh, actually, never mind. This is not the question I was looking for. Sorry. Let me find what I am looking for. Okay, the one I'm looking for, it looks like that, but that's not what the question's asking. Okay, the one I'm kind of hinting at is more like this one. So the graph shows the polar curve, and there is the equation for the polar curve for those values of theta from 0 to 2 pi. What is the total area enclosed by the graph? So you just need to be able to set it up, what the equation should look like, and then put it into your calculator. So essentially, do you guys know how to find the area of polar graphs? The area under the curve? It looks like this.
Isn't it half
Area, here, I'll write it up here. Area equals 1/2 the integral from a to b, or from alpha to beta, of f of theta squared d theta. So it's really similar to just finding the normal area under a curve. The only difference is that you have to divide it by 2, or take half of it and then square the actual function inside of there.
So you have to split it up into the two parametrics.
Yeah, so you have to like find the x and the y, right?
You can actually input it straight into your calculator in polar form. Yeah. So essentially, if you plug in the function here, the alpha to beta that we're given in this problem is from 0 to 2 pi. And then f of theta is just 2 plus cosine of 4 theta squared d theta. And then you can actually just input that straight into your calculator. Do you guys know how, or do you want me to show you?
Could you show?
Yeah, so do you guys all have this kind of calculator?
You have the
Yeah, the yellow ones.
So on the AP test, would this be one calculator section?
Yeah,
Yeah.
Yeah.
I wouldn't expect us to do this like
no.
random.
And I specifically on the test tomorrow, I put which ones are no calculator and which one you're allowed to use a calculator for. So there are 2 calculator okay questions, and the rest are non-calculator questions.
Are the BC and the AB taken this tomorrow too?
No. By the way, I was looking because as I was searching for these questions, I wanted to pull ones off of practice tests and all old release tests. So the parametric stuff is located more in the non-calculator sections, and the like series and stuff that we're going to do next, that's located more in the calculator section. So we'll be using calculators for that a lot more. And as I was looking through, there actually are a lot of questions on there about series and stuff like that. So we'll have to cover that in a lot of depth. That's why I want to spend time on you guys knowing this stuff, but I also want to move on to that because I don't want to like leave that till the very, very end, since it is, I was looking at a lot of the questions.
They said like it's the base portion.
Yeah, I was.
It's the hardest chapter too.
It can be.
I have a question. Do we have a lot left in parametrics and polars, or are we done?
This is it.
So,
So after we've learned everything about parametrics, polars, and vectors, that's it.
okay, so after we finish this, that's gonna move on to something.
Yes, that was my goal. Now you might not be 100% like 100% knowledgeable about it, but at least you've seen the material. So when it comes back time to start doing practice tests like that, you can start reviewing more of it then. Say it again.
Do you mean, are we talking about this?
Yeah.
Oh,
So like I would rather like after this test tomorrow, kind of like leave that and then move on to series stuff, so you guys can start to become familiar with that, and we can come back to this later if we need to, if you're still not familiar with it 100%. 45. Is, I believe, A.
How, what you did, I don't know.
So for this one, first things first is that we know that the formula for the area is area equals 1/2 times the integral from alpha to beta of f of theta squared d theta. So to figure out the area between the two curves, you just subtract them being squared. So it would be 1/2 the integral of the outside, so inside that one. So the outside function is 3 sine theta, so that squaring that would be 9 sine squared theta. And then minus the inside squared would be 4 sine squared theta.
Wouldn't this just be like the distant washing method type?
Similar. It is similar, yeah. So then if you subtract those, you get 1/2 the integral of 5 sine squared theta, d theta. And if you pull out that 5, you get 5/2 out front.
How do you know the limits?
That's what we're going to talk about right now. So it says, which of the following is equal to the area of the region inside the polar curve? R equals 3 sine theta, and outside the polar curve, R equals 2 sine theta. So you can figure out the limits based on, how did I do it here? It's based on where they intersect. So essentially, where will 2 sine theta equals 3 sine theta? And the only two places that those are equal to each other is at 0. Like, where will sine equal 0, essentially? At 0 and pi, right? So at theta equals 0 and at theta equals pi. So I put from 0 to pi up here, which is E. Did I say A? I meant E.
So we set them equal to each other?
Yeah, you can set them equal to each other and then solve for what sine would be. So like if you bring the 2 sine theta over to the other side, you get 1 sine theta equals 0, and then sine theta would equal 0 at 0 and at pi. For some reason though, I'm trying to remember why I thought it was A for a minute. Let me just make sure, let me trace this. 3 sine theta. This one is 2 sine theta.
Distance track or cross country? I'm in sprints.
Are you the fastest?
I was at the fastest. I was at the fastest girl. I grabbed a lot of other girls. It basically fluctuates. Overall, 3 minutes.
Okay, yeah, I think that's it. E. I'm pretty sure. I don't think it could be A because that's not the same thing.
I would have guessed B right here.
The reason it can't be, and I also think at one point was thinking that it could be